last, all credit goes to these people over here. All credit goes to these people over here, especially Dr. Sanchez. He made most of this stuff, possible notes basically. And I'm gonna say one more thing over here. I'm not screenshotting anymore because it was so laggy. That's not worth screenshotting anymore. So instead, I'm gonna write out everything a little differently, um, from normal. Actually, I think this is a normal way to write it. I don't know why I remember it differently. But it's gonna be chemical, plus radiation. And it's convention if it's positive or negative for radiation and chemicals. It actually depends on the ratio, I think. So, chemical reaction. So over here is going to be 0 because there's no, what do they call it? No, it's adiabatic, so no heat, and these are going to be 0 because there's no heat there. Now, that would mean that this is 0, which entails dx h plus u squared divided by 2 equals 0. So which means that h is 0, or the stagnant temperature, the stagnant properties, which is stagnant entropy, is constant. Now, here's the thing. We know from a long time ago that two things need to be constant for everything else to be constant for stagnant temperature, which is entropy and entropy. So we're trying to get that right now. But first of all, I want to tell you something. Over here is m dot actually. That we've yeah, if you didn't realize that, it's fine. Now you realize it. Am I forgetting something? I don't think so. Made a mistake. And then it's gonna be dm dot by rho u dx, right? Equals 0. We know m dot goes out because of the constant. So that leaves us d dx parentheses rho u square rho u plus p rho u. Ah, I see the ideal gas law. P oh, this is awkward. D dx 1 divided by rho u parentheses equals nothing. So that's what we get now. Definitely a new way of looking at it because the last way I did it was completely wrong. Um, we can now simplify here, which gives you d dx u, right? Uh, okay, plus p rho u. Now, to tell you the truth, the way we did it feels sketchy, but we're getting there, I think, with some level of something. Now, this over here with this looks like it can be something. Now, huh, okay, we got something here. We definitely got something. I'm thinking of doing a product rule here, or quotient rule here. I don't know which one would be more beneficial. And I don't remember I think it's like high D low, low D high or something. Let me just check the quotient rule. I don't remember the quotient rule. Quotient rule is high D low, low D high. Okay, I was wrong. This high D low, low D high. So it's high. So it's if I were to give d dx, right? And we do the high d low high d 1 divided by rho u. We're just testing things out because p needs to be internal somehow, which I don't get here. So oh, wait. I think we can expand this. U stays the same, d dx, right? Doesn't matter, but this over here is equal to p d dx. This goes like this, but we don't need this because we already know the same. But this over here um, becomes this, right? So it's like rho u negative 1 uh, plus 1 divided by rho u, 1 divided by rho u. No. dp dx. Whoa! I'm so happy. I don't know how happy I am that I got that. So that cancels out. Oh, then this follows the reason that we still have d dx and we have a u over here plus 1 divided by rho u dp dx equals 0. Yes. We multiply by u and it's du and dx, right? Plus 1 divided by rho dp dx. Hallelujah! Cha-ching. Yappy. All those words. You don't know how happy I am that I got that. So, yay, everything. Okay. So, u dx plus 1/2 u du dx. That equals that. So it's d dx is plus u du dx, right? Equals 0. You look over here, that's the same, right? So that idea gives you negative, I believe, u du dx, right? Plus 1 divided by rho dp dx equals 0. No, minus, sorry. So that changes this to this over here, which is h. So now we can do dh dx. I did it right? So it's over here. No, I did it wrong. So this could be minus. Oh, I did it wrong. Ignore that one. It's going to be minus plus 1 divided by rho dp dx equals 0. That is more correct, right? You see that? So Now, the secret this is basically what we call, when we did T and ds, right? That equals something. That equals, I believe it was dH plus dP over rho, and you see that's the same thing if you do a dx over here and a dx over here and a dx over here, meaning this is equal to T ds equals 0, and we know ds equals 0, so s equals 0. Boom! And that would mean, sorry, ds, which means S is constant, and entropy is constant in every location possible in a frictionless adiabatic pipe. Okay, okay. What in the world does that even entail us saying? Well, that entails us saying that we can use stagnant pressure everywhere in this whole space. So but that's just solving it out and doing it. Yeah. And then there is